Hello learners, welcome back to my channel Maths Made Easy with AB. So today in this video we will be studying about transformation of graph. So basically this is the continuation of my series Play with Graph. Earlier we have seen how to draw a straight line, how to draw parabola, hyperbola, ellipse, basic trigonometric logarithmic functions. And now if you haven't watched those videos, I'll request you to watch those first and then come to transformation of graph, wherein you will be seeing how we can transform a graph, basic function of y is equal to fx. We need to transform this graph, the first part. So let us get into this video. This is the first part. Y is equal to fx, the transformation of this graph to y is equal to fx plus minus c. I have also started a series with functions wherein I have taught about what is basic functions, odd even functions, domain, range. So I'll also urge that you see those videos and then come back to this if you want to have an understanding of what is function. So in the description I'll give you about the video link, the series link. You can go through those. Yeah. So now y is equal to fx, you need to transform this to y is equal to fx plus minus c. Y is equal to fx plus minus c. I'll solve this, explain this with the help of an example. Basically, if you get this question y is equal to fx to y is equal to fx plus minus c, the graph you need to shift by this unit on the y axis. If it is plus, you need to move plus c upward on the y axis. If it is minus, you need to move downward on the y axis. Let us understand this with the help of an example. Say for example, you have been given y is equal to e to the power of x plus 1. Y is equal to e to the power of x plus 1. So basically, your function y is equal to fx is y is equal to e to the power of x, and the value of c, is plus 1, and the value of c is plus 1. How do you draw this graph? We have already seen how to draw exponential functions. This is x-axis, this is y-axis, and this is the graph of y is equal to e to the power of x. Right guys, y is equal to e to the power of x. This point we have already seen was how much? 0, 1. Simply if we put x is equal to 0, this is the origin, yeah, 0, 0. If we put x is equal to 0, we'll get y as 1. That's why. So now y is equal to e to the power of x plus 1. What I told you, you need to shift the graph on the y axis. You need to shift the graph on the y axis by 1 unit. Very much clear? By 1 unit. I think this is clear, very much clear to you. So this becomes 0, 2, and this is the graph of y is equal to e to the power of x plus 1. Not e to the power of x plus 1. It is e to the power of x plus 1. Basically, the addition is happening in the y value. The addition is happening in the y value. Hence, the value of y increases by 1 on the graph. Right? I think this is clear to you. Now the next question. Say for example, the next question guys. The next question. So similarly, you need to understand that, I'll just draw it in this way. So this part shifts entirely by 1 unit. Yeah. So you need to understand that this part will now be looking like this. Yeah. This part will be looking like this. So, so it was on the x-axis, it was going through that, it was the asymptote on the x-axis, now it will be on the line y is equal to 1. Nothing tough, very simple, we have shifted by 1 unit. It is as simple as that, and it will go parallel to this. Now say for example, somebody has asked you y is equal to e to the power of x minus 1. How to draw this graph? So mark this line, it goes downward, and now it will move through origin. So the graph is like this. So y is equal to e to the power of x minus 1. This is the graph of y is equal to e to the power of x minus 1, and this is minus 1. Very clear? Just by 1 units it has shifted. This part is how much? 1, no? So it passes through the origin. I think this transformation of y is equal to fx to y is equal to fx plus minus c is very much clear to you. So this is the meaning of transformation. If somebody earlier was thinking what is transformation, this must be very tough or something. No. So this is the actual meaning of transformation. Let us now look into the second transformation graph. Let us now look into the second transformation graph. So the second one is y is equal to fx, the transformation to y is equal to f of x plus minus c, f of x plus minus c, right? So that addition was happening earlier, the previous part, that was fx plus c. Now this addition is happening with the x-axis. In this case, students, what you need to do, you need to do the movement on the x-axis. If it is plus, it will move this side. If it is plus, if it is minus, it will move this side. If it is minus, it will move this side by what unit? By c units. If it is plus, it will move this side, leftward and rightward. Guys, you need to understand this. If it is plus, the graph will move on the left side. If it is minus, the graph will move on the right side, yeah, towards the positive x-axis. So I'll take an example, yeah, and definitely I'll take an example to prove or show this. But say for example, you have a graph y is equal to sine x and somebody y is equal to sine x and somebody asks you to draw y is equal to sine x plus pi by 4. Somebody is asking you to draw the graph of y is equal to sine x plus pi by 4. Now this is plus. So now let me draw the graph of y is equal to sine x first. So the graph should be very much perfect. This is x-axis, this is y-axis, and I have marked the range of sine x, which is plus 1 minus 1. I think in every class of function or any class of calculus, always this comes and I draw this. Yeah, so now let me just mark it over here. This is the graph of y is equal to sine x, guys. So this is 0. This point is pi by 2. This is pi. This point is minus pi by 2 and this is minus pi. So this is the graph of y is equal to sine x. Now plus pi by 4. So basically plus pi by 4 means you have to shift this by minus pi by 4. Am I correct? It is minus pi by 4 by which you have to shift. So the graph will now become, somewhat, now the graph will somewhat become like this. So this was pi by 2, so somewhat the graph will move like this. You got this, right? So this is where it will fall. So this will reduce by pi by 4. This will reduce by pi by 4. So this will be minus pi by 4. So by pi by 4, this graph will move backward. By pi by 4, this graph, so this hump, this over here will reduce by pi by 4. Yeah, so this, I think this must be very much clear to you all. Y is equal to sine x plus pi by 4 will shift this side, will shift this side, will shift this side. By how much units? By pi by 4 units on the x-axis. Clear? If the graph they would have asked for y is equal to sine x minus pi by 4, then which side it would have shifted? Pi by 4, this side. Then it would have shifted pi by 4. So here from pi by 4, this point would have come pi by 4 over here and the graph would have moved like this. So this would have become the point if it would have been pi by plus pi by 4. I think this transformation is very simple and you must have understood how to solve, how to draw the graph of this. Yeah. So now let us see the next example. So before moving into the next transformation, let me teach you an important concept, an important graphical concept over here, which is maxima and minima, not maxima minima, drawing the graph of maxima minima. So there is one question which generally comes, let me tell you, say for example, you have been asked to draw fx is equal to max, fx is equal to max 1 plus x, comma 1 minus x, comma 2. You have been asked to draw the graph y is equal to fx is equal to max 1 plus x, comma 1 minus x, comma 2. Students, this question is very important. This question is very important. The application is massive. This question comes frequently in entrance examinations. So now understand what I need to do in this. Basically, what you have to do is you have to draw y is equal to 1 plus x. You have to draw y is equal to 1 minus x. You will have to draw y is equal to 2. And you will have to see the uppermost envelope of the graph. So now understand. Let me draw and then show it to you what do I mean by envelope. Many of you will be confused now. So y is equal to 1 by x. What is the graph, guys? So I have drawn this x, I have drawn this y. Y is equal to 1 plus x. In the very first lecture, I have taught you to draw this simply. When x is 0, y is 1. When x is 0, y is 1. When y is 0, x is how much? When y is 0, x is minus 1. So this is the graph of, let me draw it. So this is the graph of y is equal to x, 1 plus x. Y is equal to 1 plus x. Now let us draw the graph of y is equal to 1 minus x. Now let us draw the graph of y is equal to 1 minus x. So if x is equal to 0, y is 1. So this point remains. If y is equal to 0, x is equal to 1. X is equal to 1 plus 1. So this is the graph of y is equal to 1 minus x. Sorry, this was the graph of 1 plus x, right? And this is the graph of y is equal to 1 minus x. Now let us draw the graph of y is equal to 2. The next graph is y is equal to x, y is equal to 2. So y is equal to 2 is very simple. This is the graph of y is equal to 2. This point is 2. So this is the graph of y is equal to 2. Now understand, you have been asked to draw the max of 1 plus x, 1 minus x, 2. You will have to take the uppermost envelope of the graph. The uppermost envelope of the graph. So basically your graph is only this. I am just drawing this part. You need to understand. Your graph is only this. Clear? Your graph is only this. Rest all part will go away. So let me draw the graph. So rest all part will vanish. I think this is very much clear. This line was y is equal to 1 plus x. This line was y is equal to 1 minus x. Clear? And this line was y is equal to 2. So let's omit these graphs. So the resulting graph will be, what will be the resulting graph? So this was the line, yeah, and this line was coming from here, right? This line was coming and this line was going, right? And this line was y is equal to, this line was y is equal to 2, this point was 2, this was y axis, this was x axis, right? So let me draw it. And this line was y is equal to 1 plus x, this line was y is equal to 1 minus x. So this is the graph of fx is equal to max 1 plus x, comma 1 minus x, comma 2. Only the uppermost part, right? I think this is very clear. Let us now see the next question. If somebody would have asked you the min of this, min means minimum, then the lowermost part would have been the answer, the lowermost envelope. That was something like this. So we will see such examples when we come ahead. Let us now move to the next transformation, the third transformation. Let us now move to the third transformation, basically. So basically the transformation part will be continued in other videos also, since it contains several other items. So next part is y is equal to fx. The third part is y is equal to fx transformed to y is equal to a to the power of, so not this, a to the power of fx, not a to the power of fx, a into fx. Y is equal to fx is transformed to a into y is equal to a into fx. What has to be done in this video, in this question is, basically you are increasing the value of fx by a units. You are increasing the value of, so for example, somebody has given you y is equal to sin x. So sin x lies in between 1 and minus 1 and 1. But here, what will sin x lie in between? It will lie in between 2 and minus 2, or if you can say minus 2 to 2. So understand, y is equal to sin x. If the graph of y is equal to sin x is this is plus 1, this is minus 1, sin x lies in between this. So I am only drawing one part. Yeah, so this is 0. This part is how much? This part is pi. So let me mark it like this. This part is pi. Let me mark. This part is minus pi, guys. Right? Now if I ask you to draw the graph of y, and this part is how much? This part is pi by 2. This part is minus pi by 2. This part is minus pi by 2. This part is pi by 2. Understand this question. Now you have been asked to draw y is equal to 2 sine x. Y is equal to 2 sine x. So basically this will elongate, but the value on x axis will remain the same, right? So now I will just extend this part. I'll just extend this part. So this will be 2, this will be minus 2, but this graph will start from here and it will go like this. This graph will go like this. I hope this is clear to you all. This is very simple. The values, it will come the same point. So minus pi by 2 will come here. Sorry, pi by 2 will come here. So the x values will give the output, the same output, but it will be multiplied by 2. Basically. So pi by 2 was giving you what? Sine pi by 2 was giving you how much? 1. But twice sine pi by 2 is now giving you how much? It is giving you 2. So simply you have to elongate this graph. So extend it a times. Yeah. Extend it a times over here. So the graph is extended, y is equal to 8. And also remember a is greater than 0. Let us also not forget this. A is greater than 0. Graph is extended a times above or a times below according to the point. Yeah. So it is like a is 1, say for example, divide by a. So 1 by, so it will be changing accordingly. I think this is very much clear to you all. Let us now look into the fourth transformation. Students, so you can now understand what transformation of graph means basically. Yeah. So now let us see the next transformation, which is obviously you must have understood by now. I have seen stretching y. Let us now stretch y is equal to f to the power of ax. Students, if you are facing any difficulty in sketching, because this is a small area where I am showing you the graph, so what you do is, you have understood the concept, I hope, because I have already made it very clear what is stretching and what is shifting. So you draw it in your own copy, you take a bigger space, you draw it, and still if you have doubt, you can go to the comment section and post it for any doubts that you are having, and I'll try to solve it ASAP. Yeah. So now let us see the transformation of y is equal to fx transform to y is equal to f of x, where a is greater than 0. Yeah, where a is greater than 0. So what will happen in this case is, a is greater than 0. Let me write it down also. A is greater than 0. So what will happen is, in this case the stretching and all will happen in x axis. The stretching will happen in x axis. So now for example, you get the graph of y is equal to sine x, and now somebody is asking you to draw the graph of y is equal to sine 2x. Y is equal to sine 2x, right? So basically the graph of y is equal to f of ax is obtained from y is equal to fx by compressing the latter part a times against y axis. A times against y axis. So you understand y is equal to f of ax is done by compressing the graph, right? You should remember. So the first part was y is equal to fx plus c. So you were going what? You were going above, right? So this was fx plus a was going up, fx minus c it was going down. When the question was f of x plus a, you were going this side towards the negative side, and when it was f of x minus a, you were going this side. When it is y is equal to a of fx, you are stretching it, but when it is f of ax, you are compressing it. Yeah, very simple logic, this is nothing to memorize with. So y is equal to sine x, y is equal to sine 2x. Now how do you draw the graph? How you draw the two graphs? Let us just see. So you draw the x axis, you draw the y axis, and this is basically, now guys understand, this graph will always lie in between plus and minus 1. This graph will always lie in between plus and minus 1, because here there is the value is 1 only. So the maximum, so it has not been extended a times. So this part will remain plus 1 and this part will remain minus 1. So this won't change. Now what is the actual graph, guys? So actual graph, it is pi, and this part is minus pi for sine. So basically I am drawing this. So let's not write it first time pi over here. Yeah, so this is pi. So this part is pi. Yeah. this part, this middle part is pi by 2, this part is minus pi by 2, right? I think this is clear. Now you have been asked to draw the graph of y is equal to sine 2x. Y is equal to sine 2x. So what will happen in this case of sine 2x is, so say for example pi by 2, if I take it sine 2x, so this part will what? Compress, right? You are getting this part, how it will compress. So now this is y is equal to sine x goes till pi. If sine x goes till pi, sine 2x, it will go to pi by 2. Sine 2x will go to pi by 2. I'll draw it with a different color. Sine 2x, it will go to pi by 2. So basically our entire hump will complete here itself. So this will go something like this, guys. This will go something, and similarly this side also. I'm not drawing. So understand only this part, because this graph becomes complicated if I draw too many lines. Understand this part. So the black part that you can see, the black line that you can see from 0 till pi, this is y is equal to sine x. And the red part that you are seeing is y is equal to sine 2x. This red part, so this is touching, yeah, over here. Y is equal to sine 2x. I think this is very clear to you all. This is very clear to you all. So students, in the next video we will be seeing some other transformations. So this was few transformations, 4 transformations we saw in this. Yeah, y is equal. So I'll just recap this to you all. So we saw. I'm just erasing the part. We saw 4 transformations. One was y is equal to fx plus minus c. We saw y is equal to fx plus minus c. We saw y is equal to a of fx. We saw y is equal to f of ax. So these were the 4 transformations that we saw in this video. In the next video we will be seeing some transformations like y is equal to minus fx, what it happens, y is equal to f of minus x, if it is the question, what will happen. We have already seen the transformation of modulus part, and we also today saw how to draw the graph of y is equal to max of some functions, 4-5 functions given, how to draw, y is equal to min of some functions given. We didn't see min, but I told that the lowermost envelope you have to take. Try solving this problem at home. Take some example from previous year joint question and solve it. Guys, if you like the video, do subscribe to our channel. If you have any questions, just post it in the comment section. Thank you for watching.